Hello students, welcome to IMS GATE Academy. In the last session in the foundation course I started biasing of BJT and also I did study a number of the problems by using the different types of biasing circuits. Today also I would like to discuss certain number of the problems based upon the BJT. We can do one by one these questions now. Every question will be very useful for the students who are in the branch of ECE or electrical or instrumentation. I can start the problems now. By using the bipolar junction transistor, I would like to give one question here now. Please try to tackle this now. But in common emitter amplifier, shown in figure below, shown in figure below. The transistor has a forward has beta equal to 100. The current gain is given here. Beta equal to here given 100. VB is given 0.6 volts. Base to emitter voltage is given 0.6 volts. Is asking to find the values of R1 and R2. Two resistors are required. One is R1, second one is nothing but R2. Find values of, is asking to find values of R1 and R2. These two resistors are R1 and R3 is asking. R1 and R3 is asking to find. R1 and R3. Such that the transistor has the transistor has collector current of 1 milliampere. 1 milliampere it is given, and VCE equal to VCE also given in the problem, and VCE equal to collector to emitter voltage is given here now. That voltage is given as a 2.5 volts. 2.5 volts here given, and circuit diagram is given in this way. I will plot here now. This is one of the transistor. This is the common emitter configuration. Emitter is connected with a resistance of R4. Its value is given 300 ohms. Its value is 300 ohms. Here connected with a resistance R3. The voltage source is connected with 5 volts. That much voltage is given here now. And the resistance R1 is connected this side. This is R1. That value is not given. R2 equal to 10 ohms here connected. R2 equal to 10 ohms it is given. This is the given problem. What are the resistors are given? R4 is a 300, R3 is required, R1 is required, R2 equal to 10 ohms, and 5 volt supply is given here now. And values I will check once again. Beta 100, very good. VB is 0.6, okay. Then IC is given 1 milliampere. VC is nothing but 2.5. Yes, now we can start our work. What is asking in the problem? The values of R1 and R3 here now. These two resistors are required. But from the given data, how to tackle, how to find R1 and R3, I will explain now. But in a problem it is given beta is 100, no doubt. We can note down beta is 100 here. VBE given 0.6. We can note down the data at first. Base to emitter voltage is given 0.6 volts. And the transistor has collector current. Collector current is nothing but IC is given in the problem. IC is nothing but 1 milliampere. And collector to emitter voltage is given 2.5 volts. VC is given 2.5 volts. Then how we can find this R1 and R3? That is very important. But I want to make an assumption here now. The current which is passing through the R1, I wish to take as IX. IX or IR, whatever. You can take I1 or I2 or whatever. This current, after reaching to this junction, it is divided through two paths. We know very well the current which passes through this side is said to be base current of this BJT. That is the base current of the transistor. And I want to take the current which is passing through the R2 as I1. Like that I have taken here now. And also this voltage, this node voltage, I want to denote by symbol VB, base voltage I want to take. Once we know base voltage and Rx value, directly you can determine R1 value, because R1 equal to 5 minus VB by Ix. Such a way we can do. If you want to find out the resistance of the R3, you think it's so, we can apply the KVL this side. When the KVL is applied, how you can form the equation? 5 equal to IC into R3, BCE given 2.5, IE into R4. But here unknown values are nothing but, unknown value is nothing but IE. Emitter current also required. We can find each and every one of the value at first. How to find the base current? In a problem, IC is given directly, so it is not difficult to find the base current. The base current is nothing but IC by beta. Collector current by beta, I can note down. The current IC is nothing but 1 milliampere given in the problem. Beta is given as 100. This can be written as a 10 power minus 5 amperes of current is passing. That much amount of the base current is going to flow through the what? This network. And I wish to put IB you know, IC you know, you can determine this IE value. You can find IE value. And also the rest of parameters you can find. How to get IE? Emitter current is nothing but IB plus IC. Base current plus collector current, we know very well. We got base current of 10 power minus 5. The collector current is given 1 milliampere. 1 into 10 power minus 3. Then I can find what is IE. What is IE? If the addition of these two are made, you can get 1.01 milliamperes it comes. 1.01 milliamperes of current we can get. That is the emitter current I can say. That becomes emitter current only. But once you got the emitter current, you can determine R3. I wish to select the path in this direction. And I want to apply KVL here. Why we are applying the KVL here? To find R3 value. Supply voltage equal to 5 volts equal to, I can write IC into R3. IC we got as a what? 1 milliampere. 1 into 10 power minus 3 into RC, I can write. This R3, sorry, this R3 is given here now. This is R3. That's given as a R3 we can write. Its value is given as a R3 only now. So that I can put R3 into R3. R3 I can write. So I'll write clearly. This is R3 I can put. And a VC is nothing but collector to emitter voltage is nothing but 2.5 volts plus 2.5 volts plus drop across this R4 is nothing but 300 into IE. 300 into IE. What is IE? We got 1.01. 1.01 milliamperes we are getting here now. If you are using the calculator, you will get the what now? R3 value. Mostly that R3 value comes as the value of R3 you will get. If you are using the calculator, you will get R3 as that value will be R3 value 2.197 kilo ohms it comes mostly. 2.197 kilo ohms mostly it is possible. That is the value of R3 is possible. Now I wish to get what value? This R1 also required. If you want to get the R1 value, we know IB value, VB value you find at first. How to get the VB value? Just to apply the KVL in this direction. If you applied KVL, you can determine VB. VB equal to, I can write, VB equal to base voltage, VB equal to, what you are having here now? Drop across this base to emitter voltage is given 0.6. I want to put 0.6 there now. This is 0.6 plus drop across, what you are going to have? Drop across, this R4 also possible. 300 into IE. I can write 300 into IE. 300 into, what is IE? You please note down here now. The IE we got as a 1.01 milli. 1.01 milliamperes of current is possible. Then I can find the value of VB. that VB value will be 0.903 volts. 903 volts you will get. 0.903 volts mostly possible. Why this VB is required here now? To find the two parameters here now. What are the two parameters? Please watch. Once you know the VB value, you can determine I1. Why I1 is required? Ix I can get only if I know I1 and IB. Without knowing the I1 value, I can't get Ix. If I get the Ix, I can determine R1 value. That's why I1 equal to what? VB by 10. VB by 10 I can put now. I1 equal to VB by 10. VB is nothing but 0.903 divided by 10. I'll get 0.0903 amperes of current is possible. That much current is possible here now. 0.903 amperes we are getting. Why this current is required? To find Ix. Ix equal to, just now I said I1 plus what? IB. We got I1 as a what? 0.0903 we are getting. What about the base current? We got already that base current. Base current we are getting 10 power minus 5. I will put 10 power minus 5. Now you can get the Ix value. So Ix is nothing but, the value of Ix is 0.0909 031 amperes of current is possible. Now we can use this Ix value to get resistance. What resistance? We can check now. The resistance of R1 equal to 5 minus VB by Ix. R1 equal to 5 minus VB. VB is nothing but 0.903 divide by resistor. What resistor? Sorry, by current Ix. What current we are getting now? Ix is nothing but 0.0903 we can write now. Then you can determine the resistance of R1. That R1 comes as 45.36 ohms it comes. These are the values of R1 and R3 values. Yes, now we can go to next question. The next problem I want to give in your hand now. The next problem is given like this. For the given circuit, the problem is given here now. For the given circuit, assume VBE1, base to emitter voltage of first one equal to VBE2 VBE1, VBE2 equal to, here given in the problem, that is nothing but 0.7 volts. It's given 0.7 volts. That much voltage. But what is asking in the problem? The value of DC voltage is asking to find the value of DC voltage. The value of DC voltage. What voltage? VC2 is dash. That voltage is required. Now I will give the circuit here, then we can start doing this problem. Two transistors are given. The first transistor is given like this. This is connected with the 2.5 volts. This is with 2.5 volts. This is directly connected to the base. And this is again connected to the one more transistor. This is one more transistor. The resistance of 1K is connected here. this is 1K. This is connected to the ground, and this side is connected with the 10K resistor with 1 volt source, with 1 volt source. Here the beta 1 is given 100 here. Beta 1 is given 100. And beta 2 is given here 50. Beta 2 is given 50. But he is asking to find VC2. VC2 is nothing but this voltage is asking to find. Let me check the values at first. 2.5, beta 100, 10K, and also 1 volt, 50 and 1K. Yes, this is the given problem. What is asking to find in this problem? Is asking to find the VC2 value. 2 transistors are connected. One is nothing but NPN transistor, second one is nothing but PNP transistor. Those 2 transistors are given here now. But how you can determine this VC2? The voltage across this 1K is nothing but VC2. Voltage across this 1K is nothing but VC2. To find drop across this 1K, we must know the current of IC2 here must. Without knowing this collector current, we cannot get the what? VC2 value. But how to find that IC2? You watch it now. But you need to know the base current also. Once the base current of the second transistor, if you know, you can determine IC2. Otherwise, impossible. But how to find this question you asked now? Very simple way, I will do now. This voltage is given 2.5 voltage. The drop across this VBE1, this is the first transistor, the second transistor. VBE1 is given, even VBE2 also 0.7 voltage. This is 0.7 voltage. Even this voltage also 0.7 is given, base to emitter voltage is given. So we can say the voltage at this point, at what point? At this point, I selected for example. 2.5 minus 0.7 is nothing but this voltage only now. 2.5 minus 0.7. 2.5 minus 0.7 means 1.8 voltage I can get here now. This voltage will be 1.8 voltage possible. Further not. 2.5 minus 0.7 is 1.8 voltage. But again, I wish to find this node voltage here now. Why this base voltage required means by using the difference of this voltage by resistor, I can find the base current. After finding the base current, I can measure IC2. This node voltage is nothing but 1.8 minus 0.7. Because when you connected here now, when you have the voltage of 1.8, some voltage drop is done. There is a 0.8, 0.7. So this value will be 1.1 voltage we can get. 1.8 minus 0.7 is 1.1. But the base current will flow from higher potential to lower potential. Higher to lower potential means this current is the base current of second transistor. I can say this is IB2. How to find this IB2? 1.1 minus 1 voltage divided by 10K. Difference of voltage divided by resistance if it is taken, IB2 I can get now. I say IB2 I can get from this formula here now. Just Ohm's law I am applying. 1.1 minus 1 divide by 10K. By 10K. 1.1 minus 1 is nothing but the 0.1 by 10K I can write now. Finally, it becomes 0.01 milliamperes of current is passing. 0.01 is mostly possible here now. That is nothing but the base current of the second transistor. Now, using this base current, I can find IC2 now. IC2 equal to what? IB2 beta 2 into IB2 I can write. Beta 2 is given in the problem 50. IB2 we got 0.01. 0.01 milliamperes. Use calculator, then you will get IC2 of 0.5 milliamperes it comes. 0.5 milliamperes of current is possible. That is IC2. After getting IC2 value, you can find VC2. VC2 is nothing but drop across 1K. I can say VC2 is nothing but 1K into IC2, that is a 0.5 into 10 power minus 3. So 1 into 0.10 power 3 and 10 power minus 3 cancel. Finally, I am getting 0.5 voltage. This is the required value. Such a way we can find the result, I can say now, understand now. But even in the last problem you asked R1 I got, R3 also I am getting, is it not? Yes, R3 also I am getting, no problem. Yes, that's okay. Yes, I want to give one more question in your hand again now. You please try this. One more question I want to give. I wish to give one more question. For the given circuit, for the given circuit, the voltage difference between collector and emitter. Collector and emitter means we know very well. There is a VCE. We can put in the bracket VCE. It's given in the problem. This is VCE. Is asking to find that value. Is dash. That value is asking. And here the network is given like this. Transistor with emitter resistance is given 2K. This is given 2K. And collector resistance is given here 1K. This is given 1K. This is 1K. Supply voltage is given 5 volts. The supply voltage is given 5 volts. And a resistance of 1 mega ohm is connected this side. This is 1 mega ohm. And this is also connected to the ground. This is also connected to the ground. Now thereby required VCE value. This value thereby required VCE value. How to find that VCE value? First read out the problem. We can read out the problem. Then after I will do it. But what is given in the problem? For the given circuit, the voltage difference between collector and emitter is asking to find this voltage. This voltage is required. What is VCE is asking. That is the question mark. This problem is a very simple question. Anybody can understand easily now. The base is connected with 1 mega ohm and directly connected to the ground. And the emitter resistance is given 2K, that also connected to the ground. We don't find any biasing voltage for the base. Base and emitter doesn't have any biasing voltage. If it doesn't have the biasing voltage, the transistor will not be on state. Suppose this voltage source is given, means we can say that voltage source can turn the transistor on state only now. In case base is connected to the ground, this 2K resistance is connected with any voltage source, you think it so. Any voltage source is given here now. that voltage source will help to have the biasing between the base and the emitter only. But we don't have the source at the emitter, we don't have a source at the base. At the time, the transistor will come to the what? On off state only, cut-off state only possible. Whenever it is a cut-off state, the base current which is passing through this network will be 0 directly. It doesn't flow any base current. Why, sir? Base and emitter voltage is required 0.7 voltage. Here we are having the less than 0.7. That's why we can write directly I can write base current equal to 0 amperes. We know very well, once the base current is 0, this collector current will be 0. We cannot find any current this side. So collector current is 0 because transistor is off, it doesn't work. That's why because of the lack of the what now? Biasing between the base and emitter. So IC becomes 0 amperes only. That's possible. When IB is 0 and IC is 0 means IE also becomes 0 only, no doubts. But I want VCE. VCE, if you want to get, you can apply the KVL in this direction. 5 volts equal to drop across 1K is 0. There is no voltage drop across 1K. The reason is what? Current is 0. Current into resistance drop 0. This voltage drop 0 plus VCE. This is VCE. Emitter current also 0, IB plus IC. Then drop across this 2K also 0 only now. Finally, VC equal to what voltage we can get? 5 voltage I can get now. So we can write VC equal to 5 voltage. Now we can say the transistor is in cut-off mode only. In that case, VC equal to VCC possible. VC equal to VCC. VCC is nothing but 5 voltage. That is cut off. Yes, now I will give one more question. The next problem I want to give now. Question I want to give. Find IC and VCE. Find IC and VCE. Is asking the two parameters IC and VCE. But here the network given like this. The RC is given 4K. This is 4K resistor. Supply voltage is given with 9 volts. This is given 9 volts. Beta is given 99. This is beta is given 99. This is connected to the ground. And this side 400K resistor is connected here. 400K resistor is connected. And also connected with a what now? Voltage source, minus and plus. This is given 4 volts. That's a 4 voltage. This side it is connected with a resistance of 8K with a battery voltage of same 4 voltage it is given. Yes, that is the given problem. What's given? 8K, 4 volts, 400K, 4 volts, 99, 9K, 4K and also 9 volts. That's correct now. But I want this IC value. IC and VCE is asking to find. I can say this current is nothing but IC. This current is IC. The voltage across collector and emitter, this voltage is nothing but VCE now. How to find? What way we can find this value? Here I wish to take this node voltage I selected here now. That node voltage is nothing but when I apply the KVL, this voltage is equal to what a drop across this base to emitter transistor is 0.7 no doubt. Now, if not given 0.7. So same 0.7 you can have here now. Because this is equal to VB equal to 0.7. I am getting this node voltage is 0.7 voltage only. My aim is to find the base current. Initially, I wish to find the base current. After getting the base current, you can determine IC value. We are making an assumption. This transistor is in active mode. We made an assumption. But we don't know whether it is in active or not. Finally, we can check. If it is in if it is in the active mode, means the current of IC, whatever you get, is the right answer. If it is not in active mode, the collector current, what we are going to get will not be the right answer, we can say now. Now here what I did, but according to the nodal analysis, this current plus, this current plus, this current equal to 0. Summation of all the currents equal to 0, we must take. Summation of all the current 0. As per nodal, I say, as per nodal, I can take like this now, 0.7 minus 4, 0.7 minus 4 divide by 8K plus this current is nothing but 0.7 minus of this minus plus it becomes 0.7 plus what voltage? 4 divide by 400K. This current is nothing but IB. According to the nodal, summation of all the currents equal to 0. By using the calculator, you can get what base current is passing in the network. That base current comes as, that IB will be 11.8 milliamperes, you will get. 11.8 milliamperes, I am getting 11.8 milliamperes. I said already, I made an assumption, this transistor is in active mode. If it is in active mode, IC equal to, we know very well. IC equal to what? Is asking to find IC also. IC equal to what? Beta into IB. Beta is nothing but 99. IB is nothing but 11.8 milliamperes. Finally, the collector current will be, 1168.2 milliamperes I am getting here now. That much high current, 100% impossible. Well, you can check now. Yes, we got IC equal to 1168.2 milliamperes I am getting here now. We can check it is in the active mode or not by finding the VCE value. This is VCE value. VCE equal to what? 9 minus drop across this 4K. I can write VCE equal to 9 minus 4K into IC. IC is nothing but 1168.2 milliamperes. And this will be 100%, it is nothing but negative value only possible. This is negative value only. Whenever you are getting VCE in negative, we know the transistor is not in active mode. The transistor is in what? Saturation mode only now. When VCE you are getting less than 0.7 volts, the last class I explained, 100% the transistor is in saturation mode. So as it is in saturation mode, what I said, this IC is not correct. Because initially we made an assumption, transistor is in active mode, we calculated now, but it is not in active. When the transistor is in active, saturation mode, I said already in the last class, the collector to emitter voltage must be taken as a what? 0.2 voltage must. When the transistor is in saturation mode, you must select collector to emitter voltage as 0.2 voltage. After getting this VCE, after taking this VCE value, IC I can find 9 minus 0.2 by 4K. When the transistor is in saturation mode, IC value will be 9 minus 0.2 by the 4K I can take. Its value will be 2.2 milliamperes. 2.2 milliamperes it comes. This is the solution of this question. That way we can do it now. I think students followed this question clearly now. And I wish to give one more question in your hand. You please tackle now. Next question. The next problem I want to give here now. In the given circuit, in the given circuit, the silicon transistor, has beta equal to 75. Beta equal to 75. And collector voltage VC equal to 9 volts. It is given. VC is given as a 9 volts. But is asking to find the ratio of RB and RC. RB and RC means RB by RC is asking, is dash. And the given network is transistor with RC here, there is RC, and also connected with a source voltage of 15 volts. This voltage is given 15 volts. The emitter is connected to the grounds, and here connected RB here now. There is RB. This is RB. We know very well what is the name of this circuit. Yes, that is the given problem. How to determine the ratio of RB by RC? Anybody? How we can find? I don't know, please watch. What is given? In the given circuit, the silicon transistor, the given transistor is made up of silicon is given. Beta is given 79, collector voltage VC equal to 9 voltage. What is that collector voltage? This is going to be collector voltage, I can write. That collector voltage is given 9 volts. That's given 9 volts. The ratio of RB and RC equal to how much is asking? I say is asking to find RB by RC equal to how much? That ratio is required. How do you get that ratio? You know this current is nothing but the base current. This current is nothing but the IC, collector current, I can say. The addition of these two currents is nothing but current across this RC. IB plus IC. IB plus IC can also be taken as a what? IE. The name of this biasing circuit you know very well. In the last class I explained collector to base biasing. From collector to base biasing is done here now. But I wish to find initially IB plus IC equal to how much? I want to find IB plus IC equal to how much current across RC? That is nothing but 15 minus 9 by RC I can write. What I say is IB plus IC can be calculated by 15 minus 9 by RC I can write. That way I can write. That equal to how much we can say? 6 by something it comes now. 6 by RC mostly possible. This is 6 by RC we are getting. Still what I want to do, this IC equal to we know beta into IB. I want to modify such a way. IB plus IC is nothing but beta into IB. that equal to 6 by RC, I can write. Here IB I have taken common. IB equal to 1 plus beta, that equal to 6 by RC is possible here now. We know very well what is beta. I want to find what is IB now. After getting the IB, I can get the ratio, whatever it is required in the problem. Base current I can get if I apply the KVL in this direction. If I apply the KVL in this direction. In a problem, it is not given base to emitter voltage. We must take it as a 0.7, no doubt. I will write this base current equal to directly I can get now. Directly you can write now. Formula you can apply. Base current is what? Current across RB. 9 minus 0.7. 9 minus 0.7 by what I can take? RB. This is nothing but 8.3 divide by RB I can get here now. 8.3 by RB I can get now. Now this IB I wish to substitute in this equation. This IB value you try to substitute in this equation. But IB is nothing but 8.3 by RB. Beta is given in the problem. What is given? 75. 75 plus 1, 76 I can get here now. That equal to 6 by RC. But I want RB by RC. RB by RC is nothing but 8.3 into 76. 76 divide by 6 I can write. Then finally that ratio comes as 105.13 I can get here now. No units, it is the ratio only now, 105.13. That is the solution for the what? This given question only now. Now I want to give one more question here now. We can try for one more question. For the circuit shown in figure, shown in figure, it is assumed that transistor is in active region. Transistor is in active region. Directly given in the problem, it is in active region. We no need to check whether it is in active or not. Directly given, active region. And beta has large value. Then what is the value of which value required? Value of IC. Is asking to find IC value. But the given network is, I will give now, the transistor here with RC here given, and also connected with 15 volts. There is a resistor. Its value is given 430K. 430K is given here now, that resistance. And this side 10K resistor is given here. 10K resistor is given. The supply voltage is same 15 voltage. And here given 5K. This is 5K is given. That is the given problem. RC 15, 430, 10K and 5K and 15. Yes, that's the given problem. But what is asking in the problem? For the circuit shown in the figure, it is assumed that transistor is in active region. It is in active region only. Beta has large value. I said already, when the beta is very large, base current is approximately equal to 0. In the last class, I explained. In the last class, clearly I gave it. I say, when beta is very large, if it is given in the problem beta has a large value, directly you can write base current is approximately equal to 0 amperes only. Because IB equal to IC by beta. IB equal to IC by beta means beta is a very large, IC is a milliamperes only. Smaller value, smaller by larger, very small. That smaller value we are neglecting due to lack of the value of beta. So this current is nothing but the IC. When base current is approximately equal to 0, emitter current and collector currents are approximately same. Both are same only now. IE and IC are same. Because the base current approximately 0 it is taken now. Now you find this node voltage at first. This voltage I wish to take it as a VB. After getting the base voltage, apply KVL in this direction. You will get IC value. How to get this VB? VB is nothing but voltage across this 5K. Because of this supply voltage, current is going to pass across 10K and 5K. The students will get a doubt. Sir, VB equal to here, can you apply voltage divider formula or not? Because some base current may flow practically. But practically that can flow. But in this problem, we are assuming it is approximately 0 only. When the base current is approximately 0, current across 10K and 5K is same. When the same current is passing, we can apply the what? Voltage divider formula very easily now. So VB is nothing but, I say VB is nothing but 15 into 5K by 10 plus 5, 15 I can write. 15 cancel, finally I am getting 5 voltage only here now. After getting this 5 voltage, I can apply the KVL in this direction to measure IC. VB equal to 5 volts equal to base to emitter voltage not given, we need to take it as a 0.7 voltage plus drop across this 430K into IE. IE is approximately equal to IC only. IE is approximately equal to IC. Now I can find what is IC. 5 minus 0.7 divide 430 into 10 power 3. If you use calculator, the IC value comes as 0.01 milliamperes. 0.01 milliamperes of current we can get now. That is the value. That way we can get answer only now. Yes, I will go to next question now. I wish to give one more question here now. Find voltage across capacitor. Find voltage across capacitor is asking. Find voltage across. Find voltage across capacitor. Voltage across capacitor, it is given VC, but don't think VC is nothing but the collector voltage, or this is also collector. No, this is nothing but voltage across capacitor I have taken here now. Voltage across this capacitor VC I have taken here now. at t equal to 2 milliseconds, at t equal to 2 milliseconds, given in the problem, 2 millisecond. In the bracket it is given beta is very large. We know very well the beta is very large, base current is approximately equal to 0. And here the network is given in this way. Here connected with one capacitor. This is the capacitor. Supply voltage is given 10 volts. This voltage is given 10 volts. The capacitance of the capacitor is given 1 microfarad. It is 1 microfarad. That's given. And emitter resistance is connected with 1K. That is 1K resistor is connected here now. This voltage, base voltage is given 1.7 volts. This is given 1.7 voltages now. And there is one switch this side. There is one switch. The switch is open at t equal to 0 seconds. At t equal to 0, switch is open. In that case, we need to calculate voltage across the capacitor at t equal to what time? 2 milliseconds. This is the given problem. How we can find voltage across the capacitor I want? When switch is open, the time period is given 2 milliseconds. Beta is given very large. The beta is very large. This current is approximately 0. This current can be taken approximately 0 only. Base current is taken approximately 0 amperes. If it is IC, even this current also, I can put I is approximately equal to IC only now. Both are approximately equal. When switch is open, voltage across the capacitor means voltage across capacitor is calculated by what formula? That is more important now. Once we know voltage across the capacitor in time, in terms of the time t, I can calculate voltage across the capacitor at t equal to 2 milliseconds. Easily we can find. I say voltage across the capacitor we can find by integral 1 by C integral I. What current is passing this side? IC. IC into dt we can write now. IC into dt. Voltage from the networks we know voltage across the capacitor equal to 1 by C integral I into dt. No doubt from the networks. Dt integration t, I can write IC into t by C, I can write. That is mostly possible. IC into t by C. This is voltage across the capacitor. Or directly you can remember this formula, IC into t by C. But thereby required IC value. T is given, C is given. Then you can determine. How to get that IC? IC I can get by applying KVL in this direction. I want to apply K voltage law, I want to apply KVL, I want to apply. How to apply? 1.7 here. This is equal to, this voltage drop is nothing but 0.7 if not given. Drop across is 1K into IC I can write. I is approximately equal to IC. And finally, I can get 1.7 minus 0.7 by 10 power 3. This will be 1 milliamperes of current. The IC is nothing but 1 milliampere. So after knowing this value, we can find now VC value. T equal to how much is given in the problem? 2 milliseconds it is given. Then IC equal to I can find, sorry, VC equal to I can find IC equal to 1 milli. The T is given here now 2 milli. Divide by C. The capacitance of the capacitor is given 1 microfarad. 1 into 10 power minus 6 I can write. The 10 power minus 6, this is cancelled now. Finally, I am getting the 2 volts. At t equal to 2 milliseconds, voltage across the capacitor here possible is 2 voltage we can say. That is the solution of this question. And I want to give one more question. We can do this question now, one more. Next question. I will give two transistors here now. Find IC1 and IC2. Find is asking to find IC1 and IC2. IC1, comma IC2 and I0. Three parameters are required here now. IC1, IC2 and I0 is asking. Beta is very large. In a problem it is given. Beta is very large is given. Very large it is given. And the network is given like this. The each resistance of value 1K is given here now. This is 1K, it is also 1K. And supply voltage is given 10 volts. This voltage is given 10 volts. These two are connected to one emitter resistance. This is 5K. It is connected here. The resistance is given 5K. This voltage is given minus 10 volts. This current is given I0. And this base voltage is given, is connected to the ground. Base is connected to the ground. And this side, this base is connected to 3 voltage. It is connected here now. This current is given IC1. This current is given IC2. Is asking to find IC1, IC2 and I0. These three parameters are required. How to get these three parameters? That's more important. How we can get that value, those values? You please watch. But you need to understand one point in this problem. Here both transistors will come to the on state, or any one of the transistor will come to the on state. That we need to identify at first. Both are on, it is not acceptable. Why it is not acceptable means this node voltage is nothing but 3 minus, not given means base of 0.7, 3 minus 0.7. It comes as a what? 2.3 voltage it comes. 0 minus 0.7, minus 0.7 is available. At the same node, we cannot get the what? Not two different voltages. It's not acceptable now. The point what you have to remember, when two transistors are connected in such a way, is a differential amplifier only mostly, with two transistors now. Two voltage sources are given like this now. The transistor which is having the base voltage of more will come to the on state. The base voltage which transistor here having a low voltage will come to the what now? Off state only possible. That's why this transistor is a low voltage, 0 voltage, it comes to off state. This is with some voltage, it comes to on state only now. Whenever the transistor is off, IC2 is directly 0. IC2 will be 0. Because transistor is off, it doesn't allow any current to pass only now. Okay, anyhow, this node voltage is nothing but 3 minus 0.7. 3 minus 0.7 is nothing but 2.3 voltage I can get here now. 2.3 voltage only now. But using this voltage, I can find what is I0. I0 is nothing but current across 5K. I can say the current across 5K is nothing but I0. I0 equal to 2.3 minus of minus 10 divide by 5K. Whenever you are using the calculator, I0 comes as 2.46. 2.46 milliamperes of current is possible. 2.46 milliamperes of the current is possible. But here the I0, IC2 is nothing but the 0 only because it is in off state only now. Here IC2 becomes 0 only now. But IC1 and I0 will be same. The same current will flow this side also. That's why IC1 equal to, because the base current is neglected. Why we are neglecting now? Beta is a very large, base current is neglected now. At the time IC1 and this current also same only possible now. These two currents will be same approximately. That's why we can write IC1 equal to I0, that equal to 2.46 milliamperes of current is going to flow. That much amount of current will be passing in this network. But I will give the same model question one more. You will get this some idea. One more question I will give. Please watch. The question is given here. Find IC1 and IC2. The same model question with a slight change. IC1, IC2 and I0. I am asking. When beta is very large, I am giving. When beta is very large, I gave it in the problem. And the network here given is transistor this side, one more transistor this side. This side you can have RC values. That is a 1K, same I have taken for example, like this. And voltage, the same voltage, whatever I gave it before. Same 10 voltage I have taken for example. And these two are connected with some resistance. Already whatever it is given, we can put same 5K. And minus 10 voltage I connected here now. But these two I connected to the ground. This current is nothing but IC1, this current is nothing but IC2, this current is nothing but I0. But I want IC1, IC2 and I0. But sir, already you have done why you gave this. Means here the base voltages, I gave it equal values here now. This is 0 voltage, this is also 0 voltage. Both are connected to the ground. In that case, both transistors will come to the on state. Even you are connected this voltage and this voltage, some 2 voltage, this is also 2 voltage, both are on. Difference of the voltage you got means any one of the transistor will be on, I said now. But in this case, this transistor is on and also what I can write, this transistor also on state only now. Both are on. 0 minus 0.7 minus 0.7 is possible. Even you have taken this as 0 minus 0.7 minus 0.7 only possible. Now we can find easily now what is I0. We can find easily I0. I0 is nothing but minus 0.7 minus of minus 10 divide by 5K. I can write. Then I will get what is I0 here. That I0 is nothing but 1.86 milliamperes it comes. 1.86 milliamperes I can get now. 1.86. But here the two transistors are on. I want IC1 and IC2. But this current IC1, IC2 will be same. All the parameters are connected because RC1 and RC2 both are same only now. These collector resistances are same, supply is same, two transistors are identical only, they will provide in this case. Now what I wish to say, IC1 equal to IC2 equal to what I can write? IC1 plus IC2 equal to what? I0. Both are equal. Then I can write I0 by 2 only now. Half of the amount of this I0 this side, half of the amount of I0 will go this side. I0 is nothing but 1.86 milli. Divide by 2. Then finally its value is 0.93. 0.93 milliamperes of current is passing through this circuit only now. I think so far every student followed. So These are the problems based upon the biasing of the transistor. Okay then, thank you.